Hey guys, what's happening? So, it's been a while since I made a video, but I'm busy. I'm busy building stuff behind you. The mills and the lathe there back there. Alright, so I had a customer bring this in, and I mean, it's a pretty high-end product. Actually, I've never even seen one of these printers before. Yeah, the majority of the printers I work on are Crealities, and the stuff you know, like the most common printers you'd find. You know, Big Tree Tech, that kind of stuff. But, yeah, take a look at this thing. It's called a Xinkebot. But, I mean, I could tell just by looking at this thing that it's super high quality. I'll show you what I'm talking about. Company's based in China. So this guy bought this online. I guess it's a refurbished unit, but has issues. You know, he hardly got a chance to even use it, and I mean, there is some issues with the design, which actually caused the problem, which I'm here to fix. But before I talk about that, I want to show you how nice this printer is. So it's a dual extruder. I've actually never messed with a printer like this before with the dual heads. Maybe once, but it was actually more in a school setting. But yeah, I actually kind of prefer like when they're usually the double or quad. I've seen a quad nozzle. I usually like when they go into one nozzle. Just it seems like this right here would be like, okay, well this one has to get out of the way, come back. I mean, I do see the benefit of this, you know. But you know, obviously you back one nozzle away, and then you start printing over here, back the nozzle away, print over here. But definitely adds complexity to the system. But yeah, take a look at filament sensors. But I'll show you in a couple seconds when we'll go around the back. You'll see why this thing is so high end. And something you'd never see on a printer like this. I don't typically like these beds like this that are this big, because it's really hard to control ghosting. You know, when you have this huge y-axis going back and forth, this gigantic bed, it's really hard to control ghosting just because of the jerk, you know, and the velocity and the momentum. But let me show you what makes this thing unique, if you haven't noticed already. Those are actually 12-meter ball screws, SFU 1205 ball screws, or maybe 1204. So the last number, the 4 or the 5, is the actual pitch. But you never see ball screws on a printer like this. And it was, well, I mean, it's weird. It's like there's things that they cheaped out on, but then there's also things that they, like the ball screws, you know. It's just really unusual, you know. Like, in some things they just, you know, like the ball screws with the what's it called, the belt drive system here to keep them in sync. But you have a single extruder, I mean, excuse me, single stepper motor controlling this huge heavy axis, you know, with double heads, one small stepper, you know. I mean, that should be probably more than enough. I mean, you're not moving around a lot when you're just moving the Z up and down a little bit. But the issue with this printer is this ribbon cable here. So this is what actually feeds the bed, the power to the bed, and the thermistor. And I already tried soldering their wire in there to try to fix it before. But the customer can't. He went out and he's trying to find a ribbon cable, but he can't. I mean, the company won't get back to him. You know, it's just kind of a headache dealing with this thing. So, but I'm sure because if you look at this. The issue with this, see how hard 90-degree angle that is? I mean, look at the stress you're putting on that cable. When it's such a hard 90 like that, especially when you get to here, I mean, look at that. We're talking like you're pancaking the ribbon cable, which puts a lot of stress on the actual internal wires, and they break. So for this one, I mean, I've already tested before, I've already troubleshooted it, but the issue is the thermistor is intermittent. And so when it gets to a break, you'll lose your you know, feedback to the controller board. But even the controller board is proprietary. It's very unique. I'll show you that. All right, so I got to flip it around, and my idea was, I thought what I was going to do is going to put go more like a traditional style, like get rid of this ribbon system. I mean, ideally it'd be nice if you could just buy a new ribbon cable, but you can't find them. They don't get back to you. You can't buy them online. I mean, I could try to make a new ribbon cable maybe, but I would have to do a lot of crimping and it'd be a headache. And it's just going to keep on happening over and over again because of that hard 90. So, yeah, I thought I was going to do more like a traditional kind of like wire out the back here and feed it back into the control board. Alright, so here is the printer underneath. So it is actually running one of those dual displays. It's basically like a Marlin display. So it's serial. So it's basically like a mini computer. But it also acts as a Marlin display, and you can tell that because it has the dual inputs right here. And then also you have a serial input. So when you're in the graphical mode, it's acting like a mini computer, sending G-code directly to Marlin. But when you have the Marlin display, it's interfacing directly with the Marlin firmware on the board. But yeah, it's definitely a proprietary board to this company. Has a larger PCB. This is the ribbon cable that's having issues. This cable goes back that way and feeds it back that way. So the thermistor and the heated bed is on one wire. So the thermistor is here, the last two, and that's actually the issue. But what they're doing is they're taking a larger load and distributing it over multiple wires. So I got to design a system with larger wires that's no longer going to do this. And I already talked to the guy, and I told him I would probably route on the outside. But obviously this has a connector on it, so I think it's like an ST connector. I forget the name of the connector. Alright, so I know there's a couple outputs here, like if you can see in there. I don't know if that's actually a hotbed output or what it is, so I can directly wire it, bypassing this. But yeah, very annoying. You can't get this cable. It'd be nice. The problem we solved is you could find this cable. Or I could try to find where the break is. But then it would be a nightmare to have to recrimp all these connectors on there. Alright. Yeah, then it comes into here. Then this actually feeds the bed right here. So I'm probably going to have to take the bed off to run new wires in there. But yeah, it looks like it's capped on tape. Ah, man. Well, it's not going to be the easiest fix. Not the worst either, I guess. Yeah, it just makes it a little bit more difficult because this thing is really proprietary to this actual being. Look at the ribbon cable. Looks like an old ID cable. Alright. Alright, so here is a cable. You can kind of see where it's kind of screwed up a little bit right here. See that long coming all the way down right there? Especially right here. I think the channel's not big enough. I'm not sure. Well, it's a 180-degree angle. It's a complete opposite direction. It's also, the channel is very tight. So obviously there were some issues in that cable right there. So this pair right here is the one that actually is having. That's a thermistor pair. So what you have is 8 that are distributed amongst the the heated bed here, for the power, and then the thermistor is these last 2 right here. So I know it's actually running Big Tree Check 2209 drivers, Trinamics. Yeah, this board is. I'm trying to figure out. I see the bed. Well, I'm gonna do a continuity test between the connectors to see if there actually really is an extra hotbed out. And then maybe if I could find these are actually called GST. I forgot. See, there's like a thermistor out, so I don't have to go through this ribbon cable right here. If I can just directly wire from the bed straight into the board. Alright, so this is that interesting proprietary cable. So I'm still looking for a thermistor out. But what's weird is I noticed there's end stops on all the access, but you don't really need to have that. Like my 2209s are set up with sensorless homing. It just basically goes by feedback, motor feedback, by the current draw. So once it hits something right, your current will spike, and then that's how it knows that you've actually hit something. Alright, so I'm not sure if you can see that, but if you look at this connector, see it says tool 0, T0, thermistor 0. So yeah, I do actually have a JST connector I can run on here. So I can run bed power and a separate cable, but I'm gonna need actually a lot of cables. I'm gonna have to find a way to fish it down and through. Alright, so the path will be fished down here, come out this little hole I drilled right here. That's going to feed back on the hole I drilled here, and then go back into the bed. And I put some connectors on there, so in case the thermistor goes out or he has to remove the bed, he can just remove the connector. Because I could hardwire it solder in there, but you know, in case you got to move the bed for some reason, you wouldn't be able to, you know, wouldn't be able to separate it. I mean, it's actually preferred not to have a connector, because a connector is actually a failure point. You know, that's usually when you actually have burnt wires. It's usually at the connector. That's usually where it starts. So, prefer not to do that. But you know, like I said, this bed is so big and out of control that you know, you're going to need a way to remove it if you have to take the bed off. All right. So if you're wondering what wire I'm using for my thermistor, it's extremely rubbery. Look at that. That's what you want. You want a lot of flex, because the less flex you have, the more it's going to break the wires. All right, there are the wires. There are the connectors, soldered, shrink wrapped. So what I gotta do now is I might pull it back a little bit, because I need to securely fasten it here, because I don't want this to come down and interfere, obviously hit the belt and get shredded up that way. Yeah, because I mean, printers, you know, they go for, you know, sometimes days. So everything needs to be definitely tight and buttoned up. Alright, there it is. Fire this thing up in a second. Take a look. I can probably put that back. Get the right polarity was correct. Goes through, feeds up, around, into the back. Alright, let's try that. Well, before I put this back, I'm going to turn this on. Yeah, nice board. Alright. Okay, we're getting a reading. So on this one, it would actually do -14 when you wouldn't get a reading from it. So yeah, definitely a nice printer though. I mean, there's a couple of things that bug me, like these wheels. It has like the same wheels as like Creality, the wheeled access. I mean, obviously you'd think if they were to spend the money on these ball screws, they would have done linear rails too. Alright, so I'm going to heat a test. 6 degrees. Yeah, this bed takes a long time to heat up though. I mean, these large beds, so it's a huge bed, and you're only heating at 24 volts. So the Creality CR105S that I did, the 500 by 500 printer, that thing took a long time to heat up too. Yeah, because I mean, when you have a bed this big, you should be using 110 volt probably AC, versus actually trying to run out the DC power supply. You basically use a triac. You know, so you control the you know, the output of on the bed, and you connect it to a triac, and the triac would run the AC to the bed. If you're not familiar with a triac is it's a transistor, but it's designed to you know, AC DC. So you're using DC voltage to control AC. All right. So before, like I said, when the cable was intermittent, they would you would lose thermistor, and that would shut everything off. It would crash Marlin. Alright, let's get this heated up. Alright, it's still heating up. I didn't realize I had to get to 70 to 60. I'm going to flip it over, and what I want to do is make sure that the wires aren't overheating. And this thing definitely takes a long time to heat up. So if you notice, I use the same gauge of wire as the power input. So I mean, obviously you use either the same gauge or larger than whatever the power input is, because you know if it works with the power input, then it's going to work with the bed. But so typically the most power draws when the thing's heating up, but once the actual bed is heated up, you're using a lot less. You know, not using a lot less, but you're using less current once it's already heated up. So let me flip this thing over, get my camera off. Make sure that wire, it's getting a piece of plastic fall off there. Wires feel good. I mean, you're going to get a little bit warm, but not. I mean, it's not blazing hot. The main thing is usually it's the connectors that will get hot. Designed to hold a lot of current. Okay, so it's pretty hot. Okay. Yeah, looking good. Like I said, the gauge of the wire input coming in is the same gauge as the output. So always either the same size or larger. Like before, previously it was distributed over multiple wires. That's why you could get away with a thinner gauge wire. Alright, flip this back over. Alright, success. So I'm going to let this hang out here for a while, let it maintain, but yeah, that's a success. So, like I said, before you do this, and you'd lose, like whenever I get to like a break in the wire, the thermistor would go offline and then Marlin would crash. But, so if you're in the Orange County area and you want to look at your 3D printer, number's on the channel description page. So yeah, I think I've fixed like 100 3D printers by now. I fix like 1 or 2 a week, sometimes more. But alright, cool. So if you have this printer, this Xinkebot Orca 3, yeah, good luck trying to find that cable, that ribbon cable. I looked online everywhere. I even tried to find like an alternate one, replacement one, but yeah, you just can't find a 10-pin 500mm ribbon cable or a 10-pin JST connector 500mm ribbon cable. Alright guys, cool. Alright, let me know if you have any questions. Comment down below.